They're both pretty ugly looking. The left side's pretty ugly looking. The right side's pretty ugly looking. Though, by now, hopefully, you've maybe gotten the experience that if the denominator has a plus or a minus in it, that's going to be the more difficult one. I'm going to suggest that we start with this side in particular, the right side. So again, we're going to change the right side. I'm going to mess with the right side to make it look like the left side. So leave the left side alone. We're going to go ahead and manipulate the right side. Okay, the cosine of t, 1 minus sine t. We're going to multiply by the conjugate. Okay, that's a word you haven't heard in a while. So the conjugate of the denominator. The conjugate of the denominator would be 1 plus sine t. Okay, in other words, it's all the same except that this minus becomes a plus. It's a nice little trick. You'll see why in a moment. If we show you the math behind this, I have 1 minus sine t times 1 plus sine t. If I distribute, right, if I do 1 times 1 is 1, and I do 1 times this is 1 sine t. This times this is minus 1 sine t. This times this is a negative sine t squared. You'll notice that these cancel out. You have a positive 1 sine t and a minus 1 sine t. You're left with 1 minus sine squared t. But what the heck is 1 minus sine squared t? Remember the Pythagorean identity? Sine squared t plus cosine squared t is equal to 1. What if I subtract this from both sides? So remember this. Remember that when I multiply this, I got 1 minus sine squared t. But 1 minus sine squared t is cosine squared t. So instead of all of this mess down here, I can just write cosine squared t for the bottom, for the denominator. The top is going to be cosine t, 1 plus sine t. Nothing fancy there. You know this cosine squared t actually is cosine times cosine, right? Because there's two of them. So that's cosine times cosine. You'll recognize that these two cancel out. And I'm left with this, which is the same as the left side that we didn't touch. Scale from 1 to 10. Believe it or not, it's an 8. Maybe an 8.5, but it was tricky. It was crafty, right? I mean, now that you've done it, and once you start seeing the patterns, you can kind of just jump to it because you know that this is going to multiply by the conjugate. You know the middle term is going to cancel out. You know you're going to get this, and this will end up becoming cosine squared because of the Pythagorean identity. Okay, and it's a matter of just separating things and canceling things out. Again, though, notice we went ahead and expressed everything in terms of sines and cosines, and it all worked out for us. Okay, good stuff. I want you to try this one out. Pause me. You went ahead and multiplied by the conjugate. The conjugate would be 1 plus cosine t, top and the bottom. Okay. If you focus on the bottom, you end up distributing. The middle terms cancel out. 1 minus cosine squared t. But if you recall from the Pythagorean identity, that sine squared plus cosine squared equals to 1. If I subtract cosine squared from both sides, I get this right here. And we said that the denominator was actually 1 minus cosine squared. So instead of 1 minus cosine squared, I could put sine squared.
Most impressive.
Which is the same as the left side. Okay. Nice. Okay, so for the summary, notice how we did, how we went ahead and took the Pythagorean identity and came up with a new equation, right? I want you, for the summary, to write down the three Pythagorean identities in terms of sine squared theta, cosine squared theta, tangent squared theta, secant squared theta, cotangent squared theta, and cosecant squared theta. So in other words, you remember how we saw the Pythagorean identity for sine squared and it was 1 minus cosine squared? I want you to go back and for your summary, the Pythagorean identities that we did in problem 6, right? We showed you two other forms of it. I want you to use those to come up with these guys. And then, of course, fill this knot as well. Okay?